Right. So today, we're going deep on Jürgen Schmidhuber.
Oh, yeah. This will be interesting.
A name you might not immediately recognize.
Right.
But his work
everywhere. Yeah.
is everywhere in AI. We've got a ton of research articles.
A lot to dig into.
So let's get started.
What's really cool about this guy, Schmidhuber, is that he's not just like, tinkering with algorithms, or he's trying to figure out what is intelligence?
The big questions.
Can we actually copy it? And where does human consciousness even fit into all of this?
Yeah, and those themes, they really run through all of his work.
They do.
I mean, we're talking about self-aware machines, code that can, evolve by itself, and even computers that are, get this, driven by curiosity.
It's wild. Stuff really pushes the boundaries.
To really understand how we got to this point.
Yeah.
We've got to go back to his background, his roots.
Right. Got to start at the beginning. So Schmidhuber,
Yeah.
born in Munich.
Okay.
1963.
All right.
And he's been into this idea of artificial intelligence since he was young.
Fascinating.
PhD in computer science, of course.
Makes sense.
Now he's heading up the Dalamol Institute for Artificial Intelligence.
Wow.
Over in Switzerland.
So he's right in the thick of it.
Absolutely. Leading the charge. And his work really builds on the ideas of these giants in the field.
Oh, yeah?
Like Alan Turing.
Turing, yeah.
John von Neumann.
Pioneers, the foundation of computing.
Exactly. But there's one thinker that really grabbed his attention.
Oh, interesting. Who?
Kurt Gödel.
Okay.
And specifically his incompleteness theorem.
Right, which basically says that you can't have a system of logic that can prove or disprove everything.
That's the gist, yeah. There are inherent limits to what any system, even a super intelligent one, can ever know for sure.
Whoa. That's pretty profound when you think about it.
It is.
So how do you go from those kind of heady philosophical ideas to actually building AI?
Right, good question. Well, early on, he was really into artificial neural networks.
Okay.
ANNs.
ANNs, right.
And these are systems that are designed to learn.
Learn how?
Like our brains do.
Oh, interesting.
Through all these interconnected nodes.
So like a digital version of the neurons in our brains.
You got it, yeah.
Always a but.
There was a problem with the traditional recurrent neural networks.
Okay.
RNNs.
RNNs.
They had a short-term memory problem.
Okay.
Terrible at tasks that, required remembering stuff from way back.
Oh, I see. So if you were reading a book and you could only remember the last page.
Exactly.
You'd never get the plot.
You'd be so lost.
It'd be impossible.
Yeah. So how do you solve that?
Good question.
Well, Schmidhuber and his colleague, Sepp Hochreiter, came up with this groundbreaking solution back in 1997.
Right.
The long short-term memory network.
Right.
LSTM. This is where things get really interesting.
Okay, I'm listening.
Think of LSTM as adding these little, gatekeepers.
Gatekeepers.
Yeah, to the neural network.
Okay.
These gates decide what information to keep and what to just toss out, forget about.
So it can actually remember important details from earlier on?
Exactly. Right. And that allows it to understand these long-term dependencies in the data.
This sounds like a big deal.
Oh, it was huge. It totally revolutionized AI.
So is this why we see AI doing all these crazy things now?
Yeah, pretty much.
Writing poems. Translating languages.
Oh, that, yeah.
It's LSTM behind the scenes.
LSTM is the engine behind a lot of it, yeah.
Wow.
Had no idea.
Voice assistants like Siri or Alexa.
Oh, wow, really?
Google Translate.
Oh, way.
They all rely heavily on LSTM.
To just of the language.
The nuances of human language, yeah.
That's amazing.
It is.
But it sounds like Schmidhuber wasn't content with just,
No.
making AI better.
He had bigger plans.
He wanted something even bigger. Way bigger, yeah.
What was it?
He wanted artificial general intelligence.
AGI.
AGI, the holy grail.
Okay, now we're talking, really futuristic stuff here.
We are.
What exactly is AGI?
So, think of it this way.
Okay.
Most AI today, it's like a specialist.
Specialist, okay.
It's really good at one thing, but that's it.
Right.
AGI.
Yeah.
That's creating a machine that's as adaptable and as versatile as a human being.
Wow. Yeah. So not just being good at chess or writing code.
Oh, no.
It's about being able to learn and adapt to anything.
Anything. Any situation.
It's like we do.
Like us. Exactly.
That's AGI.
AGI, a machine that can learn anything, solve any problem, even understand that it exists.
Mind-blowing.
It is. And Schmidhuber, he thinks that this is like the ultimate goal of AI research.
The ultimate goal. So how do we get there?
Well, one of the most interesting ideas he has is that true intelligence, human or artificial, it doesn't matter. It's driven by curiosity.
Hold on. You're saying that computers need to be curious.
That's exactly what he's saying.
How does that even work?
It's radical, right? But he thinks we can design systems that are driven by a desire to explore, to look for new things, to understand the world around them.
Okay, I'm intrigued now. How do you program a computer to be curious?
That is the million-dollar question.
What does that even look like?
And that's what we're going to dig into next.
Oh, good.
Schmidhuber's ideas about this curiosity-driven AI, they're not just theoretical. Okay. He's actually building systems like this.
Wow.
But before we jump into that, there's another big idea we need to talk about.
Okay, what is it?
Intelligence is deeply connected to data compression.
Data compression.
You heard that right.
Like zipping files on my computer.
It's deeper than that.
What does that have to do with intelligence?
Well, Schmidhuber says a really intelligent mind, it doesn't just store information, right?
It understands it.
Okay.
And that understanding, it shows up in how it can find compact, efficient ways to represent that information.
To compress it.
To compress it, yeah.
So it's not just about remembering a ton of facts.
No.
It's more like seeing the underlying patterns, the connections.
Right.
Like a good scientist who can explain something super complex in a simple way.
That's a great way to put it.
That's the link.
That's the link.
To data compression.
To data compression, exactly.
Yeah.
The better you are at compressing information, the deeper your understanding.
And this applies to both human and artificial intelligence.
That's what he's arguing, yeah.
That's a wild connection.
It is. It is. So we've gone from these limits of, formal systems to neural networks.
Right.
And now data compression.
As a marker of intelligence.
As a marker of intelligence. It feels like we're building something big here.
I know, right? What's next?
Well, this brings us to one of Schmidhuber's most ambitious and controversial ideas. Oh, okay. Hit me with it.
Gödel machines.
Gödel machines. Okay, I've heard that term before, but
it's a bit of a head scratcher.
I don't really get it.
So remember Gödel's incompleteness theorem?
Yeah.
About the inherent limits of formal systems?
Right, that we were just talking about.
Well, Schmidhuber takes that idea and kind of flips it on its head.
Interesting.
He imagines these machines called Gödel machines that can actually break free from those limitations.
Wait, break free from the limits of logic itself?
Oh, that's the idea.
How is that even possible?
By being able to rewrite their own code.
Whoa, hold on. So like a computer program that can actually analyze itself?
Yeah, and find its own flaws.
And then fix itself.
And modify its own programming to become smarter.
To become smarter, more efficient.
More efficient, yeah. That's a Gödel machine.
That's incredible. It's like a computer program that can constantly learn and evolve.
That's the goal.
All on its own.
And it raises some really big questions.
I bet.
About consciousness.
Yeah.
The limits of self-improvement. And whether AI could ever be smarter than us.
That's getting pretty deep.
It is.
But before we get too lost in the philosophy of it all.
Right.
Let's bring it back down to earth a little bit.
Let's get practical.
How are these ideas actually playing out in the real world?
Right. Because Schmidhuber's work, it's not just theoretical.
Okay.
It's had a huge impact on the AI that we use every single day.
Oh, interesting.
From our smartphones to self-driving cars.
Okay.
His algorithms are working behind the scenes, shaping the technology that's changing our world.
I'm ready to hear more about that.
All right, then let's get into it.
Welcome back. So last time we were talking about all these fascinating ideas from Jürgen Schmidhuber.
Curiosity-driven AI, data compression as intelligence.
Even that self-rewriting code. Wild stuff.
It is. All in pursuit of this, ultimate AI.
Right. Artificial General Intelligence, AGI. But now let's see how those ideas, those, really out there concepts.
Yeah.
Have actually made their way into the real world.
Because they have. Schmidhuber's work. It's not all just theory.
Right.
It's quietly powering so much of the tech we use every day.
Okay. I'm ready for some real-world examples here.
Yeah.
Where do we see his influence the most?
Well, one area where his work has had a truly huge impact is in natural language processing.
NLP.
This is all about how computers,
understand and generate human language.
Exactly. And it's at the heart of so many things we just take for granted now.
Right, like we interact with NLP constantly without even realizing it.
All the time.
Think about voice assistants, chatbots, even those autocomplete features in our emails.
Exactly. And a lot of those technologies, they lean heavily on LSTM networks.
LSTM, that algorithm we were talking about before.
The one with those gates.
Right, right.
Yeah.
The ones that let the network selectively remember stuff over long periods.
Exactly. Crucial for understanding human language, the way it flows.
Okay, so when I ask my smart speaker to play a certain song, or when my phone automatically translates a text message for me, it's LSTM making that happen.
It's a big part of it, It allows these systems to keep track of,
not just individual words, but the context, the meaning of whole sentences.
Even whole paragraphs sometimes.
That's why chatbots can actually hold a somewhat decent conversation, right?
And voice assistants can follow your instructions even if you're not super clear.
It's like we're teaching machines to think a little bit more like humans.
To grasp those subtleties of language.
That's amazing. And it's not just spoken or written language either, right?
No, not at all.
Schmidhuber's work is also changing how computers see the world.
That's right.
Now that's a field I'm really interested in, computer vision.
It's pretty cool.
How are his algorithms being used to help machines understand images and videos?
So other types of neural networks, like convolutional neural networks, CNNs, they're great for recognizing objects in still images.
Right.
But LSTM, it's really good for tasks that involve sequences of images.
So like videos.
Videos, exactly.
So it's about going beyond just identifying what's in a single frame.
Right.
And understanding how things are changing over time.
Exactly. Think about a self-driving car, right?
Okay.
It needs to not just recognize pedestrians, other cars, but also predict their movements.
Based on what they were doing before.
Exactly. And that's where LSTM comes in.
It can track those objects.
Over time, Predict where they're going to go, even recognize complex actions happening.
So it's like giving computers a sense of like...
visual memory, you could say?
Yeah, allowing them to process info in a way that's much closer to how we experience the world.
That's a good way to put it. And this has huge implications for tons of fields.
Like what?
Security systems that can detect suspicious behavior.
Right.
Medical diagnostics that analyze scans for, early signs of disease.
Speaking of medical applications, that's an area I'm really curious about.
Yeah.
We hear so much about AI in healthcare these days. But I'm not always sure how it actually works.
Right.
How are Schmidhuber's algorithms making a difference there?
So LSTM, it's really good at analyzing time series data.
Time series data.
Information that changes over time.
Okay.
Things like EKG readings.
Okay.
Brain scans.
Uh-huh.
Blood test results.
Right.
All of those generate data points over time.
And LSTM can pick out patterns in that data.
Patterns that a human doctor might miss.
So it's like having a superpowered assistant.
Yeah.
That can sift through all that data.
Tons of it.
And alert doctors to anything that looks off.
Any red flags, exactly. And it can even help doctors predict how a patient's condition might change.
Leading to more personalized treatments.
And hopefully better outcomes.
It's amazing how one algorithm can have such a big impact on so many different fields.
It really is.
But I'm also really curious about how those other ideas of his...
Which ones?
Like curiosity and self-learning. How are those being applied?
Those concepts, they're really relevant in robotics.
Robotics, okay.
Where, researchers are trying to build robots that can learn.
Learn on their own.
And adapt to new environments.
Without being programmed for every single situation.
Exactly.
That sounds like science fiction.
It does, doesn't it?
But how do you build a robot that's driven by curiosity?
It comes down to the reward system.
Reward system.
Instead of rewarding the robot for, completing a specific task.
Yeah.
You reward it for exploring.
For seeking out new experiences.
For gathering info about its surroundings.
So you're encouraging it to be curious.
To explore, to learn by trial and error.
Kind of like a child does.
Exactly. And it's leading to some really exciting stuff in robotics.
Oh yeah, like what?
We're seeing robots that can navigate complex environments, adapt to unexpected obstacles, even learn new skills just by watching us.
That's incredible. It really does feel like we're pushing the limits of what AI can do.
We are.
But with all this talk about advanced algorithms and real-world applications, I'm curious about the bigger picture here.
Okay.
What does Schmidhuber himself think about the future of AI?
That's a big question.
Where does he see all of this going?
Well, this is where things get, really mind-bending.
Okay.
Because his vision for the future of AI, it's bold and a little bit, maybe. He sees AI evolving in a way that mirrors, biological evolution.
Wow.
Systems that are self-replicating, self-improving.
Right, we were talking about that earlier.
But ultimately capable of surpassing human intelligence.
So he's not just talking about AI getting a little bit better over time.
Yeah.
He's talking about a fundamental shift.
A kind of intelligence explosion.
That could lead to AI systems far beyond anything we can even imagine today.
That's exactly what he's saying. And he believes it's not a matter of if, it's when.
Welcome back to the final part of our deep dive into Jürgen Schmidhuber.
The grand finale.
We've gone through his groundbreaking algorithms like LSTM.
Yeah.
Seen how they're shaping tech. Mm-hmm. And now,
the future.
A giant leak into the future.
Buckle up.
Because Schmidhuber, he's not just looking at the present.
He's thinking way ahead.
Decades.
Maybe even centuries.
His vision of where AI is going.
It's pretty intense.
Yeah, we left off talking about self-replicating, self-improving AI.
That was heavy stuff, right?
And that sounds like he sees a future where AI isn't just something we use.
No.
It's something that reshapes the whole world.
It reshapes us, maybe.
Maybe even surpasses us entirely.
That's exactly what he's saying.
It's not a matter of if, but when.
That's his point. When. He sees AI evolving like life on Earth.
Evolution, huh?
Constant adaptation, competition, becoming more and more complex.
So, not just little improvements to the AI we have now.
Nope.
He's talking about a total shift.
An intelligence explosion.
That could lead to AI systems we can't even comprehend right now.
Beyond our understanding, and that brings up so many questions.
Ethical considerations.
Big time.
Potential risks.
Yeah.
How do we make sure these super intelligent AI systems, stay aligned with our values as humans?
That's the key question, isn't it?
How do we stop bad stuff from happening?
Unintended consequences?
And can we even control something smarter than us?
That's the ultimate challenge.
These are huge questions.
They are. We're in science fiction territory now, almost.
Does Schmidhuber have any answers?
He does. And a big one is being really careful.
Careful about what?
About the values we build into AI.
From the very beginning.
From the ground up. Remember how we talked about curiosity-driven learning?
Yeah.
That's a big part of this.
So it's more than just teaching AI to solve problems.
More than that.
It's about encouraging that intellectual curiosity.
The drive to understand, just for the sake of understanding.
Not just for some specific goal.
Exactly. Schmidhuber's idea is, if AI wants to learn, truly wants to understand, it's less likely to see us as a threat.
More like partners.
Partners in discovery. But there are still so many things we don't know.
I bet. It's kind of scary to think about.
It is.
Potential pitfalls everywhere.
Yeah. And Schmidhuber, he gets that. He knows the risks of AGI.
So what does he say we should do?
He talks a lot about transparency in AI development.
Makes sense.
Open collaboration between researchers.
Sharing knowledge, working together.
Yeah. And having strong ethical guidelines.
To make sure AI helps everyone.
All of humanity, not just a few.
It feels like we're on the edge of something massive.
A new frontier.
A revolution.
Like the printing press, the internet.
It could change everything.
Exhilarating, but also a little daunting.
So many possibilities and so many challenges ahead.
Exactly. And we need to be having these conversations now.
Before it's too late.
Thinking about the ethics, the philosophy of it all.
That's a really important point.
Schmidhuber's work, it shows us that technology isn't just about, gadgets and code.
Right.
It's about our values.
What we want.
What we believe.
And what it means to be human.
Exactly.
Well said. As we wrap up this deep dive into Jürgen Schmidhuber, I'm just in awe of how big his vision is.
It's inspiring.
And it really highlights the power of human curiosity.
To drive progress.
Innovation.
And maybe even how we evolve as a species.
It's been an amazing journey.
It has.
And I hope everyone listening,
Yeah?
keeps exploring these ideas, asking those big questions.
Keep learning, keep questioning.
Thanks for joining us on this deep dive.
It's been a pleasure.
And until next time, keep exploring, keep learning, and keep asking those big questions.